Okay, I will show you how to solve question number 6. Okay, the number of rabbits in a farm increases at a rate. Okay, so increase proportional to the number of rabbit at a certain time. Okay, so let's say the number of rabbit is x, because here they never said what to use, so I use x, and of course when we talk about rate is against t here. So the rabbit increase. Okay, the number of rabbit double to 10,000 from the beginning of the year 1985 until the beginning of 1990. So we look at here, is advisable you draw this graph so that we can see the things, the problem. Okay, 1985, that means we have 5,000, then increase to 10,000 when it comes to 1990. Then at that time at outbreak, that one will come back later. Now we are solving this part first. Okay, so it advisable to sketch this. Okay, this is the number of rabbit we have, x, and then this is the rate of increase, that is the birth rate, and this is the mortality rate, that means die. But here you say only they tell you about increase, they never talk about die. So increase the rate, so this is on the rate proportional to what? Proportional to the number of rabbit. So proportional to the number of rabbit, that means at this point. Okay, let's say at this point, this is t, and then this is x. So we are talking about this place, not here and not here, we are talking about here. So the rate, the gradient is dx over dt proportional to the number of rabbit. So it's this, so it's kx, but the number, the rate, the rabbit die is 0. Okay, so we can solve this part first. So how to solve? We write down the differential equation here, we write it down, and then dx over dt, then you have this. Okay, kx minus 0. Okay, then from here, after we are going to solve, this is a separable variable, so we are going to use separable variable to solve. And then when t is 1985, year 1985, we put t equal to 0, then x equal to 5,000. This is for us to find the c, the y-intercept. And then when t equals to 1990, that is 5 years later, t equal to 5, and then the x will be 10,000. This is of course for us to find the k. Okay, so that is how this is what we are going to do after this. Okay, then this is separable variable. I think this part you know how to integrate, and then you have the c, so you substitute the initial condition t equal to 0, you are able to find the c. That is how I find the c. And then I substitute the second one, t equal to 5, where x equal to 10,000, I get my k here. So this is the k. Okay, so I have got my k here. Okay, this is what we can do for the first part. Then after that, that means this will be our equation now. After we have got, this is the general solution, this is the particular solution. Okay, that means this equation is only true for this particular case. Okay, after that we read the question again. We continue. At that time, an outbreak of a certain disease occurred in a farm, which caused the death of rabbit at the rate of 100 rabbit per month. Now here, be careful, they use month, but we have to change to year, because before that we are using year, because you see just now 1985 we put 0, 1990 we put 5, that is year. So this one, after, remember, you have to change to year. So no vaccine was found until the beginning of 1992, that is 2 years later. Okay, because the outbreak is 1990 to 1992 is 2 years. Okay, 1985 to 1990 is safe, nothing happened. Only 1990 to 1992, now the rabbit will die at the rate of 100 per month. That means 1 year is 1,002. Okay, find the remaining number of rabbit that survived just before the vaccine was found. Okay, so again we look at our diagram here. you look at the diagram here. Okay, we look at this. Here, the rabbit still will increase. They will still give birth, just like before. Okay, 1985 to 1990 is still the same. That means the K is still the same as before. Everything the same. Just the difference is now that the rate of the rabbit die is 1 month 100. So 1 year will be 1,002. Okay, and then you see at 1990, because now you have to separate this one with this. Okay, this is everything safe, no disease. But here we have already the disease, so you have to look at it separately. Okay, so when the disease occur, 1990 we have 10,000 that time. So now we are asked to find how many rabbits are there in the year 1992. So it's the same. So what we have to do here, we form the equation. dx over dt, kx minus 1,002. This one because die, we have to minus. Just now is 0. This is 0, isn't it? Before that, we are not told how fast they die. We are just given how fast they increase. Okay, so this is kx minus 1,002, and then the k is just like the previous case. Okay, 1985 to 1990, there is k. We have found already is 1 over 5 ln 2. That is the k. We substitute inside. And then this one, if I use calculator, I will get 0.1386. Of course, you want to keep this also can. Of course, this is better if you take this. This is more accurate. Okay, so dx dt will be this one. And then this again is separable variable. This is a separate variable. So we are going to solve this. Okay, how to solve, I think you should know. Okay, let's see. This is a separable variable. Okay, separable variable, and then here we have, okay, the power negative. Okay, negative, so you differentiate this 1 over this, and then this is ln plus c. Okay, then we substitute our condition. Okay, like just now, look at the graph here. T equal to 1990, that is 0, we put 0, then the x is 10,000. Okay, then we can find the c, the y-intercept. So you see how I find it. Okay, I substitute. You see, I substitute t equal to 1990, x equal to 10,000. I substitute inside here, I will get my c is this. So this is more accurate. Of course, if I use the approximate one, okay, later my answer will be approximate. Okay, will be a bit different. And then from number 2, I substitute the c inside. Okay, this one you know how to solve. And then this is what I will get. So since I want to find how many rabbits are there in the year 1992, that means here 10,000, how many rabbits here? I have already got the answer for the curve. I have already got the equation. And then for 1992, I just substitute t equal to 2. Is it? Am I right? So I substitute t equal to 2. So when I substitute t equal to 2, because our t is in year. So when I substitute t equal to 2, I will get this. So finally, I will get this is the answer. I will get this is the answer. But, you see, the answer given is 10.429. There is a difference of 6 rabbits. Because why? If you want to get 10.429, you don't round up this. This one you don't round up. Okay? You make use of this. You use this one to calculate. Then you will get the exact answer. 10.429. So whichever answer you give during exam, it will be accepted. Okay? Whether you use the round up or you use the actual one, you will get the answer. You will get full mark. Depends on which one you use. So because just be different of 6. Okay? So you can look at this one, then you can try the question. After I give you another example, I will show you number 9. Okay?